Welcome back. Today's the day we're going to continue to tear apart my 356 Trans. My hope is that I'll be able to make decisions on what needs to be replaced. But first, I got to take it apart. I'm going to take it over to the workshop because they have a much taller press. I'm going to press all the gears off the pinion shaft and see what we find. When I was pushing this off the pinion gear, I had a tray underneath to collect anything that fell, like shims. Actually, there's a bunch of loose needle bearings, which I had to collect and make sure I didn't lose any. So now that we're home, I'm just gonna move things one at a time in a clean pattern so we can document how it comes apart. Just keep everything in the up position. There is a shim between these two guys here. So I'm going to put that like this. And there is a needle bearing inside here as well. So just be very careful you don't lose anything. So this needle bearing is actually a caged bearing. That guy right there. And then on this one, I can see more of the loose needles, but check it out. This one's missing one of the rollers. It's just not there. So on the first gear, the lower gear, I counted 28 per side of these needles, and this one is gone. It looks like it's just gone, missing. I'm not sure where it could have gone. Just trying to keep all these together, but if you look at the bearing, it's got some sludgy stuff on it, but I'm not seeing any breaks in the cage. It's like a brass cage. There's just one missing, and I would highly doubt that got chewed up. There's no evidence on the race. Let's look at the inside race. We'll pull this off. So there's no grooves or lines on this one. It's just a little bit dull where the bearings roll, but it's not super bad. I can't feel any wear. It's just discolored or slightly different where the bearings have been moving. But I don't see any, divots or gouges or chips where that extra bearing could have slid out. There's no way it could come out because it's captured on this side And then on the other side, it's captured by one of those heavy washers, like this washer right here. And then underneath this cup, this is the bearing that is for the first gear. So this is the one I took apart at the workshop, and I collected all the pieces and put them back in their carrier just to make sure I have the right count. So I didn't lose anything, and this one I haven't taken apart until right now. So it appears someone else put this together without that bearing. And then the other thing that's missing is on this gear right here, this guy, it has a needle bearing too. And look at that, this one's missing a roller as well. This surface looks nice, you know, slightly difference in gray between the shiny and the one that's been used, but there's no, you can touch it with your fingernail, there's no marks or grooves or depressions in it. It just so happens that this cage is missing one of the bearings, and the actual cage isn't broken. I don't see any splits or cracks or anything in the actual cage. It's just one whole roller is gone. And same thing, I don't know how this could come out without damaging the gear itself. This blows my mind that this was put together. I suspect it was put together with missing pieces. I can't think of a way where those needles would get loose and not damage internals on the transmission. Whoever put this together last time forgot the roll pin in the reverse selector shaft, the cast iron piece. Now there's 2 needles missing out of the internal gear set. And it's also got like the problem with the shafts were over torqued. So that's disheartening that this happens, but this is also why I like to do my own work, and I have the ability to take my time and source the right parts and replace bearings that are broken or missing. It's one thing if I make a mistake, but if a professional shop just most likely left something out, that's no good. This is why I do my own work. Also today, I pushed this bearing off the pinion shaft. This is the bearing that really started this whole project. I noticed a lot of wear in the outer race of this pinion bearing. So this is why I'm taking it apart. I pushed it off, but I did make a custom tool, pretty simple little donut here. That allowed me to push it off from this direction. And what I did is there's really no access to get an extractor to grab onto the inner part of the bearing. Normally when you push and pull on things, you want to push on the inner race. But the inner race, you know, it butts right up against the pinion gear. You can't get any tooling in there. And then this part of the gear was completely obscured by first gear. So I didn't see a good way to get the bearing off without actually making a custom tool which indeed pushes on the rollers themselves. Generally, you don't want to push on the rollers. So what I did is I took the old bearing race from the spare transmission and I slid that over the bearing. That prevents any of the cylinders from expanding out and losing pressure. So this keeps the bearing kind of together. And then this piece is just a nice fit that goes right over the top of the cage, right over the top of the cage, and it actually does push on this side of the cylinders. And because they're not balls, there's no point contact. So because there's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, about 13 of these rollers, my opinion was that if I push on the rollers, it's not going to deform the rollers as it's kind of spread out over all those ends of the cylinders. So that's what I did. It didn't take a lot of pressure to push it off. There's this real heavy washer on here. That is a spacer. Lay that next to the shaft. And then just underneath that is the pinion shims. And so looks like it's just, one pinion shim. So these bearing shims are very important, and that is exactly why I measured the pinion depth before I took this all apart. Because I'm going to be replacing this bearing. I know the pinion was in a good place before I took it apart. One of the numbers is written right here on the end. That's what the factory recommends this gear set to be run at. It's got a +1.3. What I had to find is the nominal dimension for the later cars is 59.22. It's hard to find it in the workshop manual, but I eventually found it in a service bulletin. I think I posted a comment in one of the previous videos because I was confused about that. So I'm hopeful that I can just push it on once and not have to change shims over and over again, because it's an exercise of getting those on and off. And of course, you always run the risk of damaging the rollers. Although on this one, I don't think I did damage the rollers. They still look fine. Get some of these things cleaned. These are all the needle bearings for one of the cages. I'm keeping them separate as much as I can. So I'm just dumping them all into this paint filter to get the dirty water out, or dirty solvent out. And then there they are inside there. There's 56 of them, nice and clean. This is what the race looks like after it's been ultrasonically cleaned. I'm just loading the next set in there. And then what I do is I just drop this whole thing in the ultrasonic cleaner and turn it on. All right, everything's completely clean. I got everything, like the threads on this are super clean now. Things are spinning really well on that. All the spacers are cleaned. These needle bearings or cylindrical bearings with the brass cages, they're just hanging out here. I've kept all the rollers in independent buckets so they will stay together. The spiders or the sliders, these things here are clean. Each of the gear sets clean. I haven't taken apart any synchros or anything, but now that they're clean, we can do some inspection. They're looking really good. This is fourth gear. It has a little bit of temperature staining on it. That's usually the one that, you know, carries the sustained torque if you're going down the highway or up a hill or something like that. But all the gears themselves look really clean. This is first gear. This is second gear. This is, I think, third gear here. Another spacer. Here's the slider. Cleaned up all between those little ridges there. And then another one of these spider things. Okay, what I found once the parts are clean is I think second gear is the worst. This is the synchro ring right here. It typically has a coating on it, and then when the coating wears through, it's bare steel. So when you see shiny metal right there, right there at the split, that's bad. And then there's also shiny metal here on the back. So this synchro is totally worn out. But in my opinion, the dog teeth, which are these guys here, that's what actually engages with the slider. And when you hear your transmission making a crunching sound, it's not actually the teeth of the gear. It's not these teeth, it's these dog teeth right here, because they have to spin up with this guy right here, and it's that grinding between the synchro goes inside here. So when this thing clips together, a lot of times that's locked, but if it's not all the way locked and it spins, that's the grinding sound you hear right there. That grinding is what you hear if you don't shift correctly, or if the synchros are worn out and you're downshifting and it's just not unable to get the speeds matched. The slider ring to me doesn't look too bad. I didn't see any metal transferred or metal, you know, mushroomed out of this. It almost feels like it's worn here in the middle, but there's supposed to be a detent there. And I can see the detent. It looks very similar to the other slider. And what happens when you put these together, it seems like there's good amount of pressure to get that to clip in. This is what keeps it in gear. There, it just popped out of gear. So I feel like the synchro's worn, but but I don't think the slider's worn to the point where it needs to be replaced. It looks like it's in good condition to me. I'll show you the other one too. Keep these separate. And then this is what, I think I call it the spider because it kind of looks like a three-legged spider, but this is what carries all the torque. It goes right from the shaft and it carries it on to this part of the slider ring. And these fit together nice. So it's a tight fit, so you got to line it up perfect. But these fit together like that, and this will slide, depending on what gear you need, it'll slide and lock at this one, or it'll slide and lock the one next to it. But because all the power is transferred, there's some wear on these guys right here. So this side's not bad, but if you look at the flip side, there's a little bit more wear. So I'll take a close-up picture of that so you can see. This one in particular is okay. I think it's the one that's on the other slider that's a little bit more worn. This guy here, this one has a detent on it. So what I could possibly do, this thing is completely symmetrical. The drive gear, the driving is mostly all the pressure's on this side when you're driving. So if I just flip it to the new good side, I don't think I need to replace this either. I'm just gonna flip it and that should work. And then on fourth gear, this is the only gear that I saw that the dog teeth are a little bit rounded. I'm going to replace the dog teeth on this one. It's the most rounded out of all of them. They don't look horrible, but you know, while I'm doing it, I should replace it. And then this is that coating I was talking about. This synchro has no wear on it at all. It looks fine. First gear looks good, other than it needs a new synchro. There's a little bit of a shiny spot there. Because first gear is used so often, I think I will replace that synchro, but the teeth look nice and sharp. And then I think, let's see, this is third gear. Third gear also needs a new synchro. It's got some wear on there, but the dog teeth are really nice and sharp. I don't see any problems with those. So I have my list here is synchros for first, second, third, and then dog teeth for fourth gear, plus the needle bearing, which is missing its needle. This guy here, and then out of here, replace the rollers on the entire bearing. I'll replace all of them together. So I'm gonna start by putting the new bearing on the pinion shaft, because I know that the shaft is fine. The teeth on this gear are in great shape. There's no pitting or galling at all on this gear. So what I'm gonna do now is I'm gonna measure the old bearing and its shim stack, which is here. And I'm going to compare that to the new bearing, make any adjustments, see if I need to order any shims. Seven, 8, 520. So this one is a little bit narrower. 78525. So if we take this and this, I got 0.78665 and 0.78510. And the old bearing is 1.5 thousandths thicker than the new bearing. And also, once again, thanks to Brendan in Australia who sent me this bearing. Now I'm noticing a couple differences. Number one, it has taller rollers. This roller is probably a millimeter taller. It also has more rollers. So if I count this, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's one extra roller, and the rollers are actually a bit larger. It's the same size bearing, but there's just less space between rollers, and the rollers are a little taller. So it's probably a heavier duty bearing, although the race or the cage doesn't look as nice as this one does. This one looks like it's riveted and nice round rivets. This one is kind of staked, but as long as it doesn't come apart, I don't see a big difference. Obviously it comes with a new race. This goes in the transmission, but the feel of these is very nice. It's a really high tolerance fit. So we get those to go together like that, and you know, it feels great. So I'm definitely going to use this bearing. This bearing is 0.0155 inches shorter than the old one. That equates to 0.04 millimeters. If we remember from the measurement, this is kind of strange, but the pinion gear was too far in by 0.04 millimeters. I was getting 59.39 and the target dimensions 59.35. So that means this new bearing puts it at exactly the right target without having to change the shims. Now my plan was to, even if it was 59.339, I could still bring the pinion, because it mounts to the intermediate plate, I can put a larger gasket on this side and it would bring the pinion gear back a little bit. But the fact that this bearing is a little bit less thick also brings the pinion gear back. So we have some adjustment. The shims are kind of a coarse adjustment here. We have some fine adjustment with the paper gasket that holds the whole case together. So we'll reevaluate it, but I'm going to go ahead and put the bearing in with even though that's slightly less tall, I think that's to my advantage. And then I can always adjust the paper gasket thickness on the intermediate plate. This will push down on the bearing. And unlike last time, I'm not going to push on the rollers. I'm going to push on the inner race, that's the correct diameter for that. Returned from the workshop again, and now we finally have our first new assembled part on this transmission. So it's going back together. It's going to be a little while before we get it fully back together, but this is a start. So rather than take apart some of the synchros right now, I'm going to wait until I get the parts and make sure that I don't lose anything in the meantime. So I'm going to store everything back on here kind of like it was. So that's it, that's the stack up. I'm just storing things here for now. I definitely left out some of these needle bearings. I'm gonna put those in a container where they can't get lost. And here's the other one, I need to order more rollers. This is for the other needle bearing, the long skinny needle bearings. This looks like it's a press fit, so I didn't wanna press it on. I'm gonna need to get things off again, so I'm just gonna store this in a box all sealed up so I don't get any dirt in this now that it's all clean.